Here you see two brands of robots, on the left brand A and on the right brand B. You can see that these robots are communicating to each other using cables that run through them. However, they cannot be connected to each other. Brand A does not talk to brand B. The reason is that robots in brand A uses a different communication protocol as that from brand B. So brand A uses Profibus while brand B used EtherCAT. Also, notice that robots need cables. Look around you. The cables are very prohibitive. If we have, let's say, another 5 robots joining the group, there are a lot of cabling work that needs to be done to join them together. Ideally, we want all robots to be able to connect to its neighboring robots automatically, creating many redundancies in case any connection fails. We want the connection as depicted on the right hand side of the slide in front of us. So, what is the solution? How can we solve this? We first make the robot communicate with each other wirelessly. We need them to communicate to each other by passing messages to one another. This distributed way of communication requires the formation of something called ad hoc mesh networks. As the name suggests, the network connection itself looks like a mesh. The second part of the solution is to make sure that the robot talk to each other using a communication method that is universal enough to work on all platforms. This is called interoperability. One way to achieve this is to use a technology we often use in the internet. Each robot can have its own IP address, like its website name, and communicate with each other as though each robot is an individual website giving services. This is through something called a RESTful interface. There are many other communication protocols that are interoperable such as this. Since we are in a mesh network, we can't rely on a centralized brain to do all the thinking, processing, and calculations. It is therefore important for this system to distribute the calculation and decision making to every part and not leave it to a master brain. Now that the devices in the automation system is connected to a mesh network, we have a lot of data that we can extract from this system. Here you see the servers makes the cloud service store and make sense of the data from the devices in the mesh network. To handle this, we need big data technology. Big data related technology provides a suite of tools to handle the type of data from such a system. It's not only large in terms of quantity, but also there are a lot of variation, missing information, and other complexities in the data in order to qualify it as a big data problem. Once we can tame all these data, we can use them to further optimize our decisions to meet our objectives. This is the function of data analytics. Lastly, in order to properly infer properties about the system from these data, our computer needs to know more about the system and how it works. Here, we need a digital model of the system. Think about it as a second digital copy of the system. So for example, if we want to make a decision to meet an objective, we do so in the digital version first and then apply it to the actual physical version. This is called a digital twin. Together with data analytics, it will enable a production system that constantly improves itself. With large amount of data used in the system, there needs to be a way to understand it as human beings. Here, visualization methods are important. You can achieve this using traditional graphs and charts, and also more modern mediums such as virtual reality and augmented reality. These two technologies are more immersive and you are able to visualize the data in 3 dimensions.